Lesson number 72 is about factors that are sums and pyramids and cones. Now we have to factor this first problem, and what we need to see in this first problem in order to factor it is that there are three different terms. We've got our first term, we've got our second term, and we've got our third term. And each of these terms is separated by subtraction. Now, in order to do this, we need to factor out our common terms. So, the common factors that we have within our terms, factor out the common factors, would be a plus b, because we see a plus b in each of our terms. So let's factor out the a plus b. We factor out the a plus b from each of these terms. Then we look at what's left over. So a plus b, we've already got it. All we have left is an x squared. Then we've got minus. We didn't have that as an a plus b. So we have an x. Then we've got minus again. And we have 6. And from here, well, a plus b times x squared minus x minus 6, we need to see if we can factor our trinomial. And yes, we can factor this trinomial. It will come out to be x minus 3 times x plus 2. And that works because negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So we got a plus b out in front still, times x minus 3 times x plus 2. This is our final answer when we factor this trinomial. Let's go ahead and look at another question. Here we want to factor out the common factors again. So each one of these terms we can see, well, the only thing they all have in common is an x minus 1. So we're going to factor out the x minus 1. Then we're left with mx squared. So we've got mx squared plus 7mx plus 10m. Now as we look at this problem, we've got to look and see if there's anything else that we can factor out. And if you notice, all three of our terms within our trinomial also have an m. So let's factor out the m. We're going to get m times x minus 1. And if we factored out the m, we're left with x squared plus 7x plus 10. And now we've got our trinomial that we need to factor. So let's bring everything down. We've got m times x minus 1. We're going to factor a trinomial, so we have to have two binomials. We know we're going to get x times x, because that's x squared. And then what two numbers multiply to 10 and add to 7? Well, 5 and 2, so x plus 5 times x plus 2. This is all we need to do to get our final answer. We've fully factored it. We've broken it down as much as we can. We can box this one and move on to the next question. Now the next part of our lesson is about pyramids and cones. And this question says, find the volume of the right rectangular pyramid. Now we're given a right rectangular pyramid. We can see its base is a square and its height is 10 centimeters. Now the volume of a pyramid is always equal to 1/3 the area of the base times the height. So in this problem, the area of the base must be the area of our square on bottom, and the area of our square on bottom is 4 times 4, which is 16. So to find our volume, we're going to say 1/3 times 16 times our height, which is 10, in order to find our answer. Well, 16 times 10 is equal to 160, so we get 1/3 times 160. So if we want to go ahead and work that out, well, 1/3 times 160 is the same as saying 160 over 3, which is 160 divided by 3, and we can solve. 3 goes into 16 5 times. That gives us 15, with 10 left over. 3 goes into 10 3 times, so we have 9. We've got a remainder of 1. So we've got 53 and 1/3. That must be the volume of this right rectangular pyramid, 53 and 1/3, and it would be centimeters to the third power. Or we could also write cubic centimeters. Got our final answer? We could box it up here, and we got it by using that formula for volume of a pyramid. It's equal to 1/3 the area of the base times the height. We also need to be able to find the volume of cones. And it's nice because the volume of a cone is the same as the volume of a pyramid. 1/3 the area of the base times the height. So in this problem, the area of the base is the area of our circular bottom. That's going to be pi times the radius squared, which is pi times 1 squared. 1 squared is 1, and 1 times pi must be 3.14. The height in this problem is 8 feet. And we're going to have to take this answer after it's been multiplied to find the product and multiply again by 1/3, which is the same as dividing by 3. So let's do 8 times 3.14. 8 times 4, well, that's going to give us 32. Carry our 3. 8 times 1 is 8, plus 3 more is 11. Carry our 1. 8 times 3 is 24, plus 1 more is 25. We get 25.12. Now we're going to have to take that answer of 25.12 and divide it by 3, because that's the same thing as multiplying by 1/3. So 25.12 divided by 3. 3 goes into 25 8 times. That's 24. We've got 1 left over, and we bring down our other 1. Decimal point moves straight up. 3 goes into 11 3 times. That's 9. With 2 left over, we bring down our other 2. 3 goes into 22 7 times. That's 21. We have 1 left over. We've got a 0 that we need to add. The 0 comes straight down. 3 goes into 10 3 times. That's 9. We have 1 left over. Whoop! We're going to get this pattern every single time, because there's always going to be 1 left over, and 3 is always going to go into 10 3 times. So our answer is going to be 3.73 repeating, with the bar showing our repetitive of 3. We've got our final answer, but that shouldn't have been boxed yet. Why not? You're right, because we need to have our label. I'm assuming you said that. So if we've got our label, well, we can undo those things. We can put our bar over our repetitive of 3, and this needs to be in feet to the 3rd power, or cubic feet. Now we've got our final answer, and we can move on to our next question. We've got a couple more today. Let's find the surface area of the right rectangular pyramid. Now if we want to find the surface area of this right rectangular pyramid, that's the area of all of our surfaces. So it'll be easiest to start with our base, because our base has a surface of 16 square inches, because it's a square, with 4 times 4 giving us our area. Next we have to look at all the faces of our triangles. And blue on top of blue doesn't work very well, so let's use an orange color. For our triangles, if the height is 8 inches, right down the middle, we've got to find the area of one triangle and then multiply it by 4, because there's 4 faces. So 8 times 4 is 32. And half of 32 is 16. So each face has an area of 16 square inches. And there's 4 of them. So we need to multiply 16 times 4. 16 times 4, well, if we looked at that as 10 times 4 is 40. 6 times 4 is 24. You can see we get our answer of 64. So we get 64 square inches. And we're going to add 16 inches to that, because that was the area of the base. 64 plus 16, that must be equal to 80 square inches. And we've got our final answer. We also need to be able to look at the surface area of a cone. That's our last problem for this lesson. Find the surface area of the cone. Now, the surface area of a cone, you can see the formula is equal to the area of the base plus pi times the radius times the slant height. Radius is often abbreviated r, slant height is often abbreviated L. And the slant height is our diagonal distance here. In this case, it's 5 meters. So the area of the base is, well, that's going to be pi times the radius squared. That's pi times 3 squared. So that's going to be pi times 9. And to that we're going to add pi times the radius. Well, the radius is 3 times the slant height of 5. Well, pi times 3 times 5, that must be equal to pi times 15. So we're going to rewrite at the top pi times 9 for our area of the base plus pi times 15. When we find those two answers, we found the answer to the problem. But in this case, pi times 9 plus pi times 15 is a very suitable way to report our answer, and our answer would have to be in square meters. I would encourage you to leave your answer in terms of pi when you can. This is one correct way to do it. If you wanted to solve the other way, you'd say 3.14 times 9, find that answer, and add 3.14 times 15, find those two answers, add them together, and solve. If you'd like to find those two answers, you may do that now, but you don't have to. Reporting in terms of pi will always get you full credit, as long as you simplify it as much as possible. Lesson practice will be on page 297. Make sure you've got your notes complete, and I'll see you during our next class.